Let's execute our kernel using clEnqueueNDRangeKernel. If we were to conceptualize in 2 dimensions, we would have a problem something like this, with work dimensions set to 2, and this line would have a 2 rather than a 1. However, to keep it simple, we'll be using only 1 dimension. The global work size is 16 because our vectors each have 16 elements in them. We'll subdivide the work into clusters of 4, so each work group is 4 elements. Therefore, the local work size is 4. The local work size must evenly go into the global work size. Let's look at this in the code. We can see 16 for the global work size and 4 for the local work size. You'll notice that all of these are 0 because 0 denotes the x-axis. We don't care about what's in slots 1 and 2 of these arrays. It doesn't matter because we're only using 1 dimension, so those other values are ignored. After calling clEnqueueNDRangeKernel, we'll get a status, and then we will check that status to make sure it is CL success. These last 3 parameters will not be used, and therefore the call should execute right away. At least that's what I have observed, and that's also what I have seen in the documentation. If event is null, no event will be created for this kernel execution instance, and therefore it will not be possible for the application to query or queue a wait for this particular kernel execution instance. With that said, let's give it a run and see what happens. I see worked clEnqueueNDRangeKernel, and I can see clEnqueueNDRangeKernel here in my code on line 558. We're good. Thank you for your time.